Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Ikram Daniel bin Zainuddin as the first presenter of our group, which is Group 9, Section 3. So I will start the presentation about the company profile, which is our mission is to involve in an international activity through an efficient business. About the vision of the Wings Electrical is to be leading contribution for the country through our business. And the objective, we are divided into two main points, which is we act as the main contractor to achieve the profitable and sustainable growth to fulfill the demand of the public. The second one is act as a contributor to give the wealth creation for Malaysia. So this organization chart of our company, which is we are stand by 5 people, which is myself, Muhammad Karenil, as the director, Nufazari is manager, Adam, Shafiq, and Amir Razi as the engineer. So, about the introduction of this project is as the high voltage student, we are required to run the project. The main part of the project is design the outdoor overhead line insulator, where the transmission line will flow to the high voltage power. As I'm certain you have been told, an outdoor overhead line insulator is used to provide electrical isolation between the conductor and the tower, as well as the mechanical support for the conductor for safety purpose by preventing any current from traveling through the tower to the ground. Okay, next about the objective. What can we give is for main point is to design the EHP to simulate the performance of design using VIA software. The third, to sketch the outlook whether in 2D or 3D using AutoCAD software. And last one is to learn the advantage and disadvantage about the each material and types of isolator. So scope of this project is the isolator must provide mechanical support. It is made from glass. It will carry 275 kilovolt. The fitting of the isolator are caps and pin. The software to simulate the isolator that being designed is VIA software. And the last one is to design by using AutoCAD software. For the problem statement, there are three main common type, which is glass, ceramic, and polymeric. So due to its weight from our problem statement, it may increase the weight of supporting structure, then will cause the breakage under excessive mechanical stress. Besides that, the use of certain amount of course will affect the decision of an isolator design. To address this issue, glass isolator will be used because the manufacturing cost is low compared to polymer insulator and much lighter than ceramic, which is able to provide good mechanical strength and durability to face various conditions in terms of weather, electrical, and mechanical stress. And the main objective of the study, of course, is to provide and propose the required specific of the glass isolator design. So I pass next to the group member.
Hi, Assalamualaikum. My name is Amirul Hazi bin Jeffrey. My metric number is AE190038. And today I will talk about technical summary for our proposed design and also technical summary for FEA analysis. So for the first one, which is technical summary for our proposed design, the chosen concept design is the cap and pin insulator are being made by glass materials. For the cap, we put it on the top, and for the pin, we put it on the bottom, allowing the insulators to suspend it from the supporting structure. To evaluate the performance, a string of 11 insulators has been modeled in a free space with supply voltage of 275 kilovolts and is applied to the 11 insulators, which is the first insulators are being grounded. So, as we can see here on the figure, is our proposed design, which is a glass insulator. What is a glass insulator? A glass insulator is an electrical insulator used in a power system. Its main structures are being made by glass shell, metal fittings, and possibly pins or bolts to attach the conductors. The glass insulators are valued for their strong electrical insulation and the ability to withstand the weather making them useful in the different power system applications. Here we have four components of the glass insulator and also with their functions, which is the first is the glass shell, which provides electrical insulation and mechanical supports to the conductors. Metal and fitting serve as attachment points for the insulator, allowing it to be secured to the supporting structures. Third is the steel pins. It is to secure the connection points for the conductors, enable them to attach with the insulator. And also finally, the cement, which is to ensure a strong and durable bond between the glass shell and the metal and fittings. So for the analysis proposed design, we can see on the figure, it is our 3D design for the type of insulator that will be used for 275 kilovolts overhead line with the chosen parameters. This figure is the 25 kilovolt glass disc insulators. And beside that, we also have a 3D design of the 11 glass insulator discs that are combined and will be used for the 275 kilovolt overhead line. As we can see, the first insulator are being grounded. We go to the technical summary of finite element analysis FEA simulation software. Most important, a few stages were expected to plan and develop to the electrostatics model from the FEA programming. For that, first things to do is we need to initialize the dialog to construct the electrostatic models. For here, we need to create a new problem, which is for our problem is the electrostatics problem. Second, we need to define the problem types and the length units for the electrostatic models. For our problems, we put the type of planar, the length units in millimeters, the depth of 1, the solver precision is 1, exponent of negative 0.008, the minimum angle is 30 degrees, and we put it on for the smart mesh. Then for the third, we need to define the coordinates value for the electrostatics models. For our x coordinate, we put 4.05. For y coordinate, we put 5.91 coordinates. After that, as we can see, we need to find the material library in FEMM software. After we find the library, we need to propose the material property selections, which is with the descriptions. Okay, first we choose glass for our property because of it is the core of our glass insulators. And then second, we choose air property because for all condition testing, which is wet, dry, pollution, and salted water. After that, we have an iron property. It is chosen because of the weather sheds of the suspension insulator. And finally, water raindrop property is chosen because of to simulate the wet situations. And finally, for the conductor conditions, firstly, we need to find the system voltage conductor on our program. We put the name of high voltage. The BC type is fixed voltage, and for our fixed voltage on the voltage conductor, we put 275 kilovolts. And for the ground conductor, we put for 0 kilovolt. And that's all from me. Thank you.
Hello and Assalamualaikum. I am Muhammad Nufazari bin Adnan and my matrix number is A190060. So now we'll explain the process flow of FEA simulation. So this is the block diagram of FEA simulation. First of all, we run the software and then we choose the problem specification, which is electrostatic problem. Then we set the problem type to planar. And then we define the boundary condition, which is ground and high voltage. Next, we define the material and conductor condition, which is glass, iron, air, water, raindrop, and salt. Design the suspension insulator into the proper coordinate. And then we set the length units into millimeters. And finally, we will run the simulation. So this is the block diagram for the process flow of FEA. Next is the technical summary, methodology, which is the problem definition in the simulation is electrostatic problem, as we need to trace the electric field intensity in the design to ensure that it works properly. Next is the problem type is plana, as the plane that encompasses the planar coil or is perpendicular to it and goes through the coil center. So based on the idea, we define the material, conductor and boundary condition. Yeah, it is critical to define the correct material because it will affect the result. And finally, the length units are in millimeters, and the system voltage is set to 275 kV. After all the parameters and properties have been determined, the design of the stacking insulator with proper measurement is carried out. So that's all from me. Thank you.
So, Assalamualaikum dan salam sejahtera. My name is Muhammad Abdaris, and I will present the part of the simulation in subject high voltage. So, as you can see, this is our insulator, our design, and our insulator made in glass. So the our one insulator equal to 11 kilovolt. So let's simulate the. So as you can see, the below insulators we inject which are high voltage kilovolt, and for the top of the insulator, which is for the ground area, which is the voltage cannot exceed the insulators. So as you can see, the blue one is the zero density voltage. So that means our voltage, we inject not exceed the area of the top of the insulator. So that means our insulator is good. So let's do a simulation for our assignment, which is the normal one, which is the normal condition is clean condition. So let's start. So this is our design, which is my mistakes. I put the wrong file. So okay, this is the real one, which is we have 11 insulator, which means can hold the 175 kilovolt from to the AC, the voltage to the top. So let's simulate the so from my explanation, the blue one is the zero density volt, and the below is the high voltage density. So the voltage did not exceed our insulators. So that means our insulators design is very good. So we just plot the graph first. So for our voltage, so as you can see, this is our potential volts. So this is for our magnetic field. And so we took the field intensity. So as you can see, the density just occur in the high voltage area. So let's move on to the wet condition, dry condition. So as you can see, our dry condition have a set in our top insulators. As you can see, when the transmission lines near at the C, the C will have of course the automation line have a set in the top of the glass. So let's So for our dry condition, so the dry condition we have a slat in top of the insulators. So why we put the slat in our insulator? So because when the dry condition, the salt from the seawater will appear in the insulators, because sometimes in transmission line, when the transmission line near the sea, so this condition will occur. So let's simulate first. So this is the density voltage. So let's plot the graph for the volt and magnitude. So this is our voltage volt. So for our magnetic field intensity, so this is our graph for the magnetic field. So for our field intensity simulation, as you can see, just have a field intensity at the area of the high voltage, same as the normal condition, clean condition. So let's move to the wet condition, which is we have a raindrop at the top of the insulators. So this is the density of the voltage. As you see, the top do not get the voltage from the high voltage at the bottom area. So let's plot the voltage first. So this is our graph for the voltage volts. So this is our electric field for the so let's send our voltage to the field intensity. So same with the clean and dry condition, the density have occurs at the high voltage area. So that's all for me. So we can go through the result and discussion from Shafiq Aika. So his will explain more about the graph and the simulation. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafiq Akar bin Suradi. My matrix number is DE200055 and I'm from Section 3 Group 9. So today I would like to present about my part, which is simulation result. So firstly, this is the simulation result of clean condition in normal states. So in figure 1, this is the simulation result of clean condition of the glass insulator, which is in normal state using FEMM software. So next is the figure 111, which is the field intensity of glass insulator in clean condition in normal states. So the blue region in this simulation is the field intensity. So next is the wet condition, which is raindrop. So for the figure 2, this is the simulation result of wet condition of the glass insulator in FEMM software when hit by raindrop. So this is during the raining day. So this is the simulation result that we get, and then for figure 2.1 is the field intensity of the glass insulator in wet conditions. So the blue region is the field intensity. So next is the dry condition, which is salt. So for dry condition, this is the result simulation that we get in figure 3. So the simulation result of dry condition is salt. For example, when being in a coastal area that has the phenomenon of seawater evaporation using FEM software. So this the dry condition, which is salt, occur when the insulator is nearest in the beach, and when the phenomenon of sea evaporation. So next is the figure 3.1, which is the field intensity in the during the dry condition, which is so next is the result and discussion. So the voltage versus length graph of the glass insulator. So firstly is the clean condition. So this is the voltage versus length graph, and then wet condition, and then the dry condition. So all of this is a voltage versus length graph. So the voltage potential graph of the insulator show the same pattern in clean, wet and dry condition, which can be seen by referring the voltage versus length graph. So the electrical potential indicates that the voltage will gradually decrease from 275 kV all the way down nearly to 0 volts. So this means our insulator is working well. Next is the field intensity versus length graph of the insulator. So the first is the clean condition and wet condition. Lastly, the dry condition. So out of these three is the field intensity of length versus length. So the discussion is the field intensity versus length graph show that the normal state, the presence or absence of moisture, which is water, has very little effect on the field intensity of the stacked glass insulator. So this is shown by the fact that there is very little difference between the three figures of graph. So that's all for me. Thank you.
In a nutshell, to maintain the performance and safety of glass insulator, it is critical to adhere safety norms and regulation throughout the design process. For this project, 275 kV glass insulator was chosen because it is more resistant to breaking than ceramics and has 1.5 times the mechanical strength of ceramics. The insulator was designed using AutoCAD by using the standard measurement and components, and also it will be simulating using the simulation of FEA software under its specification. So that's all from us, from Group 9, Section 3. Thank you.